Hey everyone. So today we'll be talking about this Leetcode problem, valid parenthesis. So we are given a string containing just the characters, the brackets, open and closed, then we have curly braces, and then we have the square brackets. And we need to determine if the input string is valid. Okay, so what is a valid string? An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Okay. So let us consider this example over here. We have a open bracket and we have a closed bracket. So this is a valid string. Similarly over here, every open bracket is has a corresponding position of its closed bracket over here. Okay. And an invalid string would be we have an open bracket here, but we don't have a closed bracket. Similarly, we have a closed bracket here, a closed square bracket, but we don't have an open bracket. Also, a string where we have a closed bracket and an open bracket like this. Okay, so basically this is also an invalid string because it has to follow the sequence. We should be having a open bracket followed by a closed bracket. Okay, all right. So the first thing that comes in my mind is that we will need to have some kind of a stack data structure that we need to use. So over here the stack data structure would mean that we want to insert some elements and at the same time we need to pop from the elements or those elements. Now which elements we'll want to insert? We'll want to insert all the open characters over here, all the open bracket, the open square bracket and the open curly bracket. And the moment we identify that our topmost element in the stack is an open bracket and the next character in the string is a closed bracket, will immediately pop from the stack. Okay, so similarly in case of this, wherein we have a square bracket which is in the stack. Okay, now let's say the character that we are trying to traverse is a open bracket. Okay, that means we will have to put it inside the stack. Only remove this bracket from the stack when we encounter a corresponding closed bracket when we traverse the string. So this will be much easier. Okay, let's consider this example wherein we have little complicated example wherein we have this kind of situation over here. Okay, so what happens is, let us say our string is this. Okay, uh, this is our string. Okay, so we first initialize the stack. It is 0 of size 0. Okay, then we traverse through this string. We encounter this open bracket. Okay, we check in the stack. Since this is an open bracket, we'll have to insert in the stack. So our stack becomes this. The zeroth element in the stack becomes this. Next, we come over here in the next string. This is also an open square bracket. So we'll have to insert it into our stack. Then we encounter a curly bracket, okay, which is an open curly bracket. So we insert it into the stack, okay. Next, we encounter a closed bracket. The moment we encounter a closed bracket, it means that we'll have to check on the top of the stack. Do we have an open bracket, a pair? That does it form a pair? Yes, it forms a bracket. So we pop from the stack. Then we encounter this closed square bracket. Okay, now we have to check in the stack. Is it that does the top element form a pair? Does it is it a open square bracket? Yes, it is open square bracket. So we pop from the stack. And then this last character. Okay, so this is a closed bracket. So we check in the stack. We have a open bracket here. They form a pair. So we pop from the stack. Now our stack size is 0. So after traversing the entire string, if our stack is of size 0, that means whatever we have traversed is a valid string. If there is some item in the stack and its size is not equal to 0, that means it is an invalid string. So we return false. Alright, so let us look at the code. Now in JavaScript, We don't have to, there is no a separate data structure as stack or something. In JavaScript, arrays can be considered as a stack. Why? Because we have a push method in the array which allows you to push items towards the end of the array. We have a pop method in the array which allows you to remove the last element from the array. That means we follow the LIFO structure. So the last in element is the first one to get out of the stack. So it is last in, first out. Alright, so let us start writing our code. So we have to initialize a stack over here first. Constant stack, we'll call it stack. It has to be of type array which has all the elements as string. Okay, so let's initialize it to 0. Is an empty array. Okay, and I am thinking that we can have a lookup object. Let me first write and then talk about it. So this lookup object will be of type a key which will be of type string and the value will be of type string. Okay, and this object will basically look like something like this. Uh, The open bracket and its value will be the closed bracket over here. Then we have a open square bracket and its value will be a closed square bracket. Then we have open curly bracket and its value will be a closed curly bracket. All right. Okay. So this lookup object basically will help us in identifying and matching the strings, the pairs when we traverse the string. Okay. So let me traverse the string and then we'll see how this lookup object is helpful to us. So for let I equal to 0, I less than s dot length I plus plus. So we need to, in this array, we need to push items to the stack. So for this string, we need to push items to the stack and we need to pop items from the stack. So first we'll check whether our string is this. Okay, so if in our stack we have this open bracket, so we'll check this. So if lookup of s of I, okay, so s of I, for example, over here, if we consider the string, initially we come over here, okay, and the stack is empty. So first what we'll do is we'll just let me first insert, assuming that the stack is empty. So what we'll say stack dot push s of I. Okay, so we're inserting into the stack. But we also first need to check. Okay, so let's say initially we come over here. Now the stack is empty, so we have inserted this open bracket. Now next time we come here and we've encountered this. Okay, so every time we need to check in the stack. So we'll check that if our lookup object of s of I. Okay, so basically this is equal to s of I. Okay, so if s of I is this closed, and we need to check the in the stack we have to check. So we have to check in stack over here. No, we have to do like this. We have to check. Okay. Since our stack is going to be dynamic, first let me extract the length over here in a separate variable. And I'm doing -1. Why? Because I want to check the, so a stack is going to be of 0 index. So if there is one element in it, then I have to check the zeroth element. Okay, that is why I'm doing this length. So now if stack of this last element, okay, is equal to s of I, basically this lookup of s of I. Okay, then we need to pop from the stack. Else we push in the stack. Okay, so let me just reiterate over this what happens. Now we traverse the string in the for loop. We find the length of the stack over here. Okay, and then we check what is the last element, the topmost element in the stack. So is the topmost element of the stack is equal to, we have to do like this. We have to say lookup of. Okay, so the topmost element is going to be this initially in our situation this. Okay, and we now next element is this. So we'll have to say is the lookup of the topmost element. Okay, this topmost element is this, and its lookup is equal to this over here is equal to s of I, then say stack dot pop. So we remove this element from the stack. Okay, and otherwise we insert the element in the stack. Okay, and what do we return? We need to return true or false. So if our stack size is equal to 0, that means while traversing the entire string, we were able to, systematically insert and remove the pairs. So at the end, our stack is still empty. So what we say is we say stack dot length is equal to 0. So if this is true, stack dot length is true, is 0, that means it is true. Otherwise, it will return false. Okay. So let me run this. Right, and submit. Okay, so we have got a acceptance. So this is an easy problem, but quite an interesting problem, wherein we get to actually use the stack data structure. But we know that in JavaScript, arrays can be used as stack because they have this push and pop methods.